Hello, today we wanna just continue with another sessions that is about the stoichiometric coefficient, and specifically we continue with the second example that is how many moles of nitrogen would react with excess hydrogen to produce 2.24 decimeter cubic of ammonia at STP. So from the questions that I seems in such a way, the things that you must perform, first of all, you must balance the chemical equations. Since in part of stoichiometric coefficients, we try to look on the part of relationship that exists between the product and the reactant in terms of moles. So from that, first of all, we must know that the nitrogen gas, it was reacted with hydrogen gas to release the product that is ammonia, and this one is gas. So from this part we're going to balance this is in part of stoichiometric. We try to look on the part of moles, how it's balanced from product and the reactant. If you want to look here, this equation, it is not balanced, so it will be in part of reactant there is 2 nitrogen, but in part of product there is 1 nitrogen, so we put 2 here in order to balance the number of nitrogen. See, since here the number of nitrogen is already balanced, so up there now we're going to back on the part of hydrogen. Here in part of reactant there is 2, and part of product there is 6, so up the end we put here 3. So up right now the equations is already balanced. So from that, the thing that we're going to extract from this information is about the number of moles that exist between the question that we have asked about nitrogen and the ammonia. So it means that the nitrogen gas now have ratio with ammonia in terms of moles from the balanced chemical equation is 1:2. So if you have that concept already captured into your mind, it will be easier to continue with the calculations. So from that, I read back again and look for another aspect, and from that balance the chemical equations. The things now that we're going to look much is to find the number of moles of ammonia, since we have given the volume. Since from our question here we have given the number, we have given the volume. Volume is 2.24 decimeter cubic at STP, and also in part of reactant or nitrogen here we have asked you to find the moles. So we find the moles from this correlation. So after getting this information up the end, now we're going to back on the whole concept. So from that I will say that any 1 mole of any gas at STP is equal to 22.4 decimeter cubic. So it means that ammonia is a gas, so it will be 1 mole of ammonia. It will be equivalent or equal to 22.4 decimeter cubic. So how many moles of ammonia will be produced when 2.24 decimeter cubic? You see, so up the end we cross multiplication. So up the end it will be moles of ammonia at STP. It will be equal to we take 1 mole times 2.24 decimeter cubic divided by 22.4 decimeter cubic. So this decimeter and decimeter will cancel out. So at the end our answer will be, let's plug into our calculator, it will be 2.24 divided by 22.4. So the number of moles, it will be equal to 0.1 moles. So these are more of ammonia at STP. So from the balanced chemical equations, the relation that was existed between the ammonia and the nitrogen gas, it was 1:2. So from this 1:2, we're going to use it into the correlation. So it will be 1 mole of nitrogen gas is equivalent to 2 moles of ammonia from the balanced chemical equation. So how many moles of nitrogen gas will be in 0.1 moles at STP of ammonia? So we cross multiplications. After crossing the multiplication there, it will be number of moles, nitrogen moles, it will be equal to, so now it will be 1 mole times 0.1 mole divided by 2 moles. So this mole and this mole will cancel out. At the end, it will be 0.1 divided by 2. So the answer, it will be equal to 0.05 moles. So from these calculations now, we're going to look at how many moles of nitrogen gas would be reacted with excess. So it means 0.05 moles of nitrogen gas that will be required to produce 22.4 to produce 2.24 decimeter cubic of ammonia at STP. So this is the answer. Thank you.